If we were to zoom in on a hydrogen atom and make the nucleus about the size of a baseball, the electron would be about 4 kilometers away and be about the size of a period in any textbook that you're reading. There's a lot of space between the nucleus and the electron. What I want to do here is figure out the electric force between the proton and the electron. Instead of E, I'll just write negative. Okay, so we need to figure out some things here. First, well, let's say that I need to get my color straight. The charge on the proton is the same as the charge on the electron. It's just negative here on the electron. So I could say that this is E positive, which is 1.60 times 10 to the negative 19th coulombs, a constant for the charge of a proton. So this must be E negative, which is negative 1.60 times 10 to the negative 19th coulombs. Okay. What about the mass of both of these? Well, the mass of a proton is 1.67 times 10 to the negative 27th kilograms, while the mass of an electron is 9.1 times 10 to the negative 31st kilograms. And this separation is about 0.053 nanometers, which is the same as 0.053 times 10 to the negative 9th meters. Okay, so let's try and put some things together to come up with our electric force. If we have more charge on one of these sides, it should make sense that the force is bigger. So the electric force depends on both of the charges, Q1 and Q2. So Q's represent the charges of the particles. It must also depend on the separation distance. So and it should make sense that if you separate these particles, the force goes down, meaning that this variable r will be on the denominator, and that r is squared. So that is the distance between the particles. And we could also figure that it's all it's related to these terms and possibly times a constant k, where k is 9.0 times 10 to the negative 9th. And this looks very similar to Fg, right? This looks similar to Fg, where the force of gravity equation was G times m1, m2 over r squared. Both of these are fundamental forces, and they also appear the same in their form. If I were to plug in, say, my masses to this force of gravity equation and my charges to the Fe equation, I would find this. That Fe for these two particles is about 8.2 times 10 to the negative 8th Newton, because we're talking about a force. And the force of gravity on these two particles is about, if you're plugging in all of your knowns, 3.6 times 10 to the negative 47 newtons. So Fe is way bigger, way bigger than Fg. Fe is about, in fact, it's about 2.3 times 10 to the negative 30, or to the 39th power, larger than Fg. It is enormous compared to Fg. Fg is very, very weak. this electric force plays out in all of our contact forces. So we are familiar with, say, the force like normal force and tension force and friction forces. All of these are contact forces. We have normal, we have tension, we have friction. But all of these arise because of the electric force. Meaning that if I go to, this is my finger, and I am pushing a block, when I go to apply, this is an applied force. When I go to push this block, the electrons in my finger are pushing against the electrons in the block, and those two are repelling each other, causing this motion, this acceleration of the block to go in that direction. So the fundamental force for all of our contact forces is the electric force. Fundamental force is the electric force for contact forces. Okay, that's all for now. I'll see you guys soon.